let's suppose we have a synthetic problem where we are given a specific starting material and a specific target, and the question is how to transform a starting material, if you like, or starting material into a target molecule, or TM, target molecule, or synthetic target, if you like. So how do we go from the starting material to the target? Now, in this case, what we look at is always, well, two things, okay? The change in the number of carbons, whether it's increase, decrease, or the same. And of course, when we say change, we mean here, it is implied the change in the target molecule. In other words, does the target molecule have more carbons than the initial starting material, or less number of carbons, or the number of carbons stays the same? So that's an important point to look at, is the change in the number of carbons. So we look at the change in the number of carbons, whether it's increase or decrease or the same. So increase is possible, and of course this is where the challenge is, of course, is increase. Decrease is also possible, or the same if the number of carbons stays the same. Of course, if the number of carbons in the target molecule is more than the starting material, then we should think of ways by which number of carbons increases. And here, for example, we think of, let's say, Grignard addition to carbonyl compounds, because Grignards or Grignard addition to carbonyl compounds give alcohols always with more carbon. So Grignard addition, we can think of, for example, cyanide attack on alkyl halides in substitution reactions. That's where the number of carbons increases by 1. We can think of Grignard carboxylation, for example. That's an excellent method, of course, to make carboxylic acids. We can think of cuprate addition, for example, on acid chloride. So if it's an increase, therefore, we can think of Grignards as one possibility. We can think of cuprates as another. We can think of CN minus, if you like. In other words, of course, in general, the reactions by which the number of carbons increases. If it decreases, then probably ozonolysis, because that's really one way to reduce the number of carbons, is to cleave carbon-carbon double bonds. So if you like, cleavage here in general, that results in reduction, if you like, or decrease in the number of carbons in a target molecule. If it's the same, of course, there is no challenge here because the number of carbons is the same. So probably then maybe it's functional group transformations only. So that's actually the second point. So the first point, again, is the change in the number of carbons. The second point is functional groups. We look at functional groups in the target molecule and we compare them with those in the starting material, and we see where the change is. For example, if the number of carbons is the same, but here, for example, we have an aldehyde and there we have a primary alcohol, so that's a simple reduction. If we have, for example, a secondary alcohol and here we have a ketone, so that's simple oxidation of a secondary alcohol into the corresponding ketone. So it's not just, therefore, the number of carbons that we look at also the change in function groups. So these two items are really important whenever we have a synthetic question or a specific transformation from a specific starting material into a specific target molecule. We look at the number of carbons and we see if there is a change, if it's the same, decrease or increase. And of course, if it's increase, it's the more interesting, the more challenging. What are these methods or reactions that can, or by which the number of carbons increases? We look also at functional groups in order to see how we can transform a specific functional group into another. Of course, keeping in hand or keeping in mind, of course, the change, or if there is a change in the number of carbons, for example, Grignard addition results in transforming a specific functional group into another, but also with simultaneous increase in the number of carbons. What we'll do next is we take specific examples of synthesis and we take what's called the backward approach in order to lead us to a specific or a narrow approach or a specific way or method, if you like, by which we can transform a starting material or a specific starting material into a desired target molecule.